Welcome back to episode 4 of Learn AI from Scratch series. So far, we built a machine learning model that predicts house prices based on area. But here is the real question. Is the model actually any good? Sure, we get predictions, but how do we know if they are close to reality? That's where the evaluation metrics like MAE, MSE, and R square come in. I agree, those are all new jargons, but let's focus this episode on them. So, from the previous episode, we gave a data and we converted it to a data frame and then we predicted. So here are the prediction numbers, right? But how do we know they are the right numbers or not? How do we measure the error rate? So what is an error rate? It is the difference between the actual number and the predicted number. So we have the actual numbers and predicted values. So can we use them to compare and know whether we got a good result or not? What is the math behind these calculations? We know for an area of 500, the price is 150,000, but the predicted value is 158,279. So we see that there are little differences. How are we going to use it to our advantage? So here is the math behind all that. You see the actual values, and these are the predicted values. Error rate is just the difference between prediction and actual, right? So absolute error. You might have learned it in your elementary school that when you make an absolute value, you draw two lines next to the numbers and you just remove the minus, right? That's exactly what we are doing here. And then you are squaring the numbers. In the sklearn metrics, there is something called mean absolute error, mean square error, and R2 score. Mean absolute error is nothing but taking a mean of the sum of all these numbers. So it is as the name sounds. Mean squared error, you just take a mean of all the sum of these numbers, the squared errors. That's called the mean squared error. So you basically take the error out of each row and then add it with the next one and finally take an average out of it. That's exactly what we are doing. And R2 score, what does it say? When the model is able to explain the differences from the actual and the predicted value, that is, it has the control over the output, and that's a higher valued R2 score. Let's see this in action now, right? We have already predicted this Y here, and now we are going to see the MAE and MSC. Okay, but I want to see the numbers. Yes, so be it. Oh, that's huge. 6,939. Another number is way too high to even be spelling it out. So let's at least see the R2 score because R2 doesn't depend on the scale of the X and Y numbers. If it is closer to 1, I'm good. If it is closer to 0, then my model is bad. It's 0.98. That's a very good prediction, right? But still, I'm not convinced. I want to see the MAE and MSC in a scale that I can understand as a human. So let's bring the inputs and outputs to the scale that we understand. So in sklearn pre-processing, there is a module called min-max scaler. So it takes all the numbers, it finds the minimum and maximum out of it, and converts each number according to the minimum and maximum so that it is scaled between 0 to 1. Okay, now our x and y is completely scaled. With the scale numbers, we are going to find MAE, MSC, and R2. I'm also excited to see the output. First, to give you the context, let's see the inputs that we had in the scaled version. Remember, it used to be 800, 500, and now it's all between zeros and ones, right? And now the MAE and MSE. Oh, this is good. This is really good because the error number is pretty close to zero than it is closer to one, which means the error is minimum. And here the R2 scale number doesn't change at all. It is still 0.98, which is very good for us. So we see that our output is really good. Next time someone builds a model, don't just look at the predictions, check how well it's actually performing. In episode 5, we will start with the actual classification of how machine understands between an yes and a no, spam and a not, or cat versus dog, like this. See you soon.